Here we are on chapter 8. Hopefully you did great on Tuesday with your test. I'll get those scores out to you as soon as I can. They'll be typed into the Canvas probably before they're released, but I have to wait until everybody's done to get that. So what we're starting on now is chapter 8. And if you have that unit circle that I sent you, on the back side are all the identities that we'll be using here. So make sure you print that out. Here is your trig identities for sum and difference formulas. And let's do a little bit of proving here. We know let's use the sine sum formula. So notice the order. Pay attention to the order of the pluses and minuses. If I'm adding, then I'm adding over here. If I'm subtracting, using the bottom. This isn't a plus or minus formula. This is two formulas, the top formula and the bottom formula. So if there's a plus, if you're adding the angles, then you're going to be adding over here. If you're subtracting the angles, you'll be subtracting over here. Now that's different for the cosine formula. If you're adding over here, you'll be subtracting on the other side and vice versa. So make sure you pay attention to the signs and to the formulas. So let's use our sine sum formula. And we're going to see if this and this are the same. And we'll be able to determine that using our formula. So this side is equal to the sine of pi over 2 times the cosine of pi plus the cosine of pi over 2 sine of pi. Now we want to know if that's the same as this side. If we simplify this other side, we know that the sine at pi over 2 is 1, and the sine at pi is 0. So we end up with 1 on this side. So what we want to happen, if this is true, you're going to get 1 on the other side. So let's find out if that actually happens. So the sine at pi over 2, we said, was 1. The cosine at pi is the x. I get -1 plus the cosine at pi over 2 is 0. The sine is 0. And so I get -1 equals 1. So right there is a cute little proof of, nope, we can't just distribute. This is not the same as this. This has to be ran through the formula for you to get the right answer. Okay? And another way just to test to see if that's true, I know that the sine of pi over 2 plus pi, well, that'd be the same as 3 pi over 2, and the sine at 3 pi over 2 is indeed -1. So, but we're not going to be able to do that on all of these, where you can just check it the easy way. So make sure you have those. Hopefully by now you have your unit circle printed out. If not, pause this thing and get it, because I'm going to be referencing it over and over and over again. So use the above identities to simplify that. So I'm going to say this is sine of pi over 3 plus 30 degrees. So I'm mixing together radians and degrees. That's okay, because we can find each of those. So I'm going to plug that into my sum formula for sine, which gives me the sine at pi over 3 cosine 30. And in the sine formula, they're the same. Cosine pi over 3 sine 30. And let's find some of those answers. The sine at pi over 3, sine is the y value, gives me 3 over 2. The cosine at 30 is the x, root 3 over 2, plus the cosine at pi over 3, and the sine at 30. And if I multiply square root of 3 times square root of 3, I get 3 over 4 plus 1 over 4 gives me 1. All right. Continue using the identities in both directions. So let's take a look here. If I expand this out, I'm going to have sine of t cosine pi over 6 plus cosine t sine pi over 6 minus the quantity, because we're going to expand that out. We're going to want to use this. So I'm going to say sine t cosine pi over 6. Now, because this one's minus, I'm going to be putting a minus here, and it's going to be the cosine t sine pi over 6. And let's do a little simplifying here. Sine of t. The cosine at pi over 6 is root 3 over 2 plus cosine t. The sine at pi over 6 is a half minus the sine of t. The cosine at pi over 6 is root 3 over 2 plus, because minus times minus, right? And so I'm going to have plus cosine t sine is 1/2. And if you notice, we have a sine t root 3 over 2 and a minus sine t root 3 over 2, so they go away. And if I put these, I got a half of a cosine of t plus another half of a cosine t. Gives me the answer of 1 cosine t. All right. So using these identities helps me to be able to do some identity simplifying, basically. So if I want to compute the 5 pi over 12, well, up until now, we've known what we're splitting this into. Here, they tell us we have to figure out what to split that into. So what I'm going to do is I'm going to start out by saying, well, cosine at 5 pi over 12 is the same thing as 3 pi over 12 plus 2 pi over 12. And I can simplify that further for making it easy to find some of these answers. This is pi over 4 and pi over 6. Now we have the sum of cosine. And if you remember, the sum of cosine, the signs are the opposite. So if I'm adding over here, I would be subtracting over there, because the sign on the top goes with the sign on the top. So I'm going to use my cosine formula, which says cosine pi over 4 times cosine pi over 6 minus sine pi over 4 sine pi over 6. And let's simplify that down. We're going to probably get stuff like root 2 over 2. Cosine at pi over 6 is root 3 over 2 minus. The sine at pi over 4 is root 2 over 2. And the sine at pi over 6 is 1/2. Simplifying that down, I get the square root of 6 over 4 minus square root of 2 over 4. And since it has a common denominator, I'm going to write it with my common denominator. So square root of 6 minus square root of 2 all over 4. And that's simplest form for that, because we don't have any radicals in the bottom. Now, there's an interesting thing here. What happens if I would have picked different numbers for my cosine? If I would have said, instead of this, if I would have said something like cosine of 9 pi over 12 minus 4 pi over 12 and used a subtraction formula. Would I have gotten a different answer? Well, hopefully, because this is math, that doesn't happen. So let's plug into that formula and see if we get a different answer or do we get the same answer. And if I simplify 9 pi over 12, I end up with 3 pi over 4 minus pi over 3. And let's substitute into that cosine formula with the same stuff. Let's use black this time. Cosine 3 pi over 4, cosine pi over 3. Notice that the minus sign in front of that pi over 3 doesn't become the negative on that. It's just part of the formula. And then we have a plus, because in the cosine, the bottom sign is a minus, then over here it becomes a plus. So then I have sine 3 pi over 4, sine pi over 3. Now hopefully this comes out to be the same thing. Boy, that'd be sure be embarrassing if it didn't, right? So let's simplify. The cosine at 3 pi over 4 is negative root 2 over 2. The cosine at pi over 3, cosine is the x, gives me the half. And then we have plus, the sine is root 2 over 2, and the sine at pi over 3, sine is, and it appears as if we're going to end up with negative root 2 over 4 plus root 6 over 4, and I think that's what we ended up with last time. Okay, so we end up with the same answer both ways. And let's see here. Prove that the cofunction identity for cosine. So this is a cofunction. If you look on the sheet that I sent you, cofunction identities are two groupings up from the sum and difference formulas on your sheet there. And so we're going to prove that that exists. So to do a proof, this is the simplified sign. So that's what we want it. That's what we want it to equal when we're done. So I'm going to use my cosine formula, and I'm going to say cosine pi over 2, cosine, I don't know, alpha. And because that's a minus, this would be a plus on the cosine. And then I get sine pi over 2, sine alpha, maybe. I'm sure somebody will look it up and tell me which one it is. And I'm going to have the cosine at pi over 2 is 0 times cosine alpha. Sine at pi over 2 is 1 times the sine of alpha, which gives me sine alpha. So we can prove some of these cofunction identities using this same stuff. All right. So I'm going to stop because it looks like I have about a minute left on this video, so I'm going to stop there.